Now we're going to turn to the firm's expansion path. This is what we left off with in at the end of chapter 6. We're going to look in more detail at the firm's expansion path before using it to derive the firm's total cost equation. So here we can see both the firm's long-run expansion path and the firm's long-run total costs curve graphed with the expansion path on the left and the total cost curve on the right. So notice for the firm's expansion path, it's really showing how that firm's going to grow in its use of inputs, capital, and labor as it increases the amount of output that it is producing. So when the firm wants to produce 10 engines, for example, it's going to be at point X, where it's using a given amount of capital and labor that costs it $100 for the production of those 10 engines. If we jump to point Z, it's showing us how, when the firm increases production to 30 engines, how it increases its use of capital and labor and is able to produce those 30 engines at a cost of $300. So graphing on the right-hand side, quantity produced against the cost of producing that amount of output, we're able to then draw the firm's total cost curve. So in the previous slide, we saw the firm's long-run expansion path. We can also look at their short-run expansion path and derive from that their short-run total cost equation. So here we see both the long-run expansion path as well as the short-run expansion path. And what I want you to really note is that while our long-run expansion path in the yellow here is upward sloping, the short-run expansion path is perfectly horizontal. It's this blue line. And that's because in the short run, capital is fixed at 6 units. Right? So in the short run, the firm's not able to adjust how much capital they use. They can only change the amount of labor. And so it means that any level of production, for the most part, will involve a higher cost. Okay, so we can look at point X prime. Right there, we see the firm is producing 10 engines in the short run, where it can only use capital of 6 units. It can't use any more, it can't use any less. And so it's having to use less labor than it would like to. So if we see that movement then from the short run to the long run, we see the firm adjust away from capital. So it's using less capital and increasing the amount of labor it uses so that it is able to produce those 10 engines now at a lower cost, right? Rather than being 120, which it was in the short run, now the cost is $100. We can compare that to point Z and Z prime, where again, the firm is stuck at 6 units of capital at Z prime, which means that they're having to use more labor than they would want to in order to minimize their cost fully. So in the short run, they're producing 30 engines at that higher cost of $360. And then as we move into the long run and they're able, and they're able to adjust their capital, in this case, increase it while decreasing the amount of labor used, they move to point Z and they're able to produce the 30 engines now at the cheaper cost of $300. So with these two curves, these short run expansion path and long run expansion path, we see some of the key assumptions behind producer behavior coming up. Right? In the short run, capital is fixed, right? So it's not going to change. And that's going to mean that the firm can effectively minimize its costs, right? In the long run, both capital and labor can change. We get that upward sloping long run expansion path as a result, as well as perfectly optimized costs or perfectly minimized costs for the firm's production goals. Okay. So now we can step to deriving the firm's total cost curves from the firm's expansion path. All right. So again, we're on the left here looking at both the firm's long-run expansion path in the yellow and their short-run expansion path in the blue. So for our short run, when capital is fixed at 6 units, if the firm is producing 10 engines, their costs will be 120. So if we look over to our total cost curve graph, at an output of 10 engines, the firm has X prime at a cost of 120. Right? We compare that to the long run optimal point of X, where those 10 engines are made at $100 instead. Okay. For Y, the long run and short run optimal is the same. So that point is the same on both the short run and total and the short run and long run total cost curves. And then moving to point Z and Z prime, for the output of 30 engines in the short run, the firm is using less capital than they want to. So for producing 30 engines, their costs are going to be 360. So that point lies higher in the short run than it does in the long run when the firm is able to adjust and increase the amount of capital it wants it's using and decrease the amount of labor, moving its cost down to that $300 level. All right. And so what that's going to translate to when we connect all these points together is what you're seeing in this right-hand side graph. The total cost curve for the firm in the short run is always going to be higher or equal to costs in the long run, right? So we see our total cost curve for our long run production lies below that of the short run production. So to define the cost curve for us explicitly, right, a cost curve is just going to be that mathematical relationship between a firm's production cost and its output. The short run is going to describe total costs of producing various amounts when capital is fixed, whereas the long run is going to show the total cost of producing when both capital and labor can change, right? So this is essentially what we were discussing previously. Okay. And then the slides include a larger image for you there so you can see the difference between the short run and long run total cost curves a little bit more easily. All right. And then this final slide makes the point that I articulated earlier, right? In the short run, costs will always be higher or equal to, never below, costs in the long run, right? Because in the long run, the firm can adjust both their inputs, allowing them to better minimize their costs. This relationship between short run costs and long run costs, you're going to see repeated when we look at average costs and marginal costs in the short run and long run. So just keep that in mind, right? Keep in mind that key distinction between short run and long run. In the short run, capital is fixed. And in the long run, both capital and labor can vary. Okay. And that distinction, again, gives us where in the short run, production will cost more than it will in the long run. Okay. So with that, we'll end here. And the next video, we'll pick up discussing total, fixed, and variable costs.